Comparing scientific notation, remember any number that's in scientific notation basically has two parts. So the first part is going to be our decimal number. Let's just call it the decimal number, although technically you'll probably hear it referred to as the coefficient sometimes. So let's say we're working with the number 2.5. That's the coefficient. And then times, let's say 10 to the second power. Okay, we've got 2.5 times 10 to the second power. And let's compare it to the number 8.6 times 10 to the third power. So in this circumstance, we can look at the exponent to determine which number is bigger. So the first place we'll always look when comparing scientific notation is at the exponent. So the exponents here, what are the exponents that we have, Emma?
We have 2 and 3.
Yeah, so we've got 10 to the second power here, so that's 2, and then 10 to the third power, which is 3. And so we can determine that one is bigger than the other really fast just by looking at the exponents, right? So we've got 2 and 3. 3 is bigger, so 10, that number, 8.6 times 10 to the third, is going to be larger. But I would like to prove it to you. And the way I can prove it is, let's convert both of these numbers really quickly into standard form, meaning we actually go through. So can you do that on your paper real quick, and I'll do it on the screen? So how did you convert 2.5 times 10 to the second power into standard notation?
I moved the decimal to the right 2 times.
Totally, 1 and 2. So the new decimal is here, and let's put that 0 here, and then we'll get rid of this. So we have 250. And then for the other number, what did you do?
I moved it to the right 3 times.
1, 3. Put that decimal there, fill in my zeros. Let's get rid of that first decimal. Okay, and so now it's pretty clear. If I was asking you, hey, what's bigger, 250 or 8,600, right? And I put that decimal and there's a 0 there. Then it's pretty clear, right? 8,600 is a lot bigger. So if we have if we've got two numbers in scientific notation and those numbers have larger exponents, the number with the larger exponent is the larger number. But sometimes the numbers have the same exponent. So let's do another example down here, and maybe this one I'll do in dark blue. So let's say we've got 8.87 times 10 to the fourth. And then we've got, I'm going to make a line here to make it clear. So we've got 8.87 times 10 to the fourth. And then we've got 8.42 times 10 to the fourth. What do you think is bigger there? How might we determine it?
I think the one on the left is going to be greater.
Why do you think so?
Because if you look at all of the numbers in the problem and you compare the 8 and the 4, 8 is going to be greater.
Totally. So that's perfect. Well, first we determined, hey, both of these are multiplied by the same exponent, so 10 to the fourth, which we could just remember is actually 1 with 4 zeros behind it. So this is 10,000. So we're multiplying both of these numbers by 10,000, all right? And if we have the same exponent in our scientific notation, then we compare our decimal number. So let's start over here by comparing in purple the number in the ones place. Okay, well in the ones place we have 8 ones in both numbers, so we know they're even there. So let's move one more place to the right. Now we're going to look at the tenths place. Okay, here we have 8 tenths in one and then 4 tenths in the other. So right there we can say check, this number is going to be bigger. And just to prove it, let's rewrite these numbers in standard notation as well. So let's rewrite this down here. We've got 8.87. I've got 8.42. And in both cases, Emma, how do we move our decimal to convert from scientific notation to standard notation?
In both, you move to the right 4 times.
Yep. So 10 to the 4th. So we move to the right 1, 2, 3, and 4. Then 1, 2, 3, and 4. I'm going to clean this up really quickly so it looks good. Got our decimal there, add our 0, add that last 0 there just so we're clear. Erase this first decimal. And so now let's look at these numbers again. I'm going to erase this so that it's a little bit easier to read these numbers. Maybe even put commas so it's nice to read. So here we have 84,200, and here we have 88,700. And now it's really obvious, right? Like this is the larger number. Cool.
So in scientific notation, if we're going to be comparing scientific notation, will we ever have fractions in the problems?
In scientific notation, we won't really be dealing with fractions, since scientific notation is pretty much always decimal, not pretty much, it's always a decimal number times your 10 to an exponent. But it could get a little bit trickier. Like, what do we think about this here? What if we have 5.75 times 10 to the negative 4th, and then we're comparing that to 6.83 times 10 to the negative 4th. How do we compare those? Which one would be bigger?
Will it be the one on the left?
It will be the one on the right. So to find out which one's bigger, we first compare our exponent. So in both cases, they have the same exponent. So after we compare the exponents and they're the same, okay, well now we have to look at, in green, our decimal. And so which is bigger, 5.75 or 6.83?
6.83.
Totally. So this one is going to be bigger. So this is going to be bigger. But again, I think it's always nice, especially when we're starting, to just like prove it to ourselves by writing it out in expanded or standard notation. So we can do that really quickly. Here we've got 5.75, and over here we've got 6.83. And in both cases, it's 10 to the negative 4th. So we're going to move the decimal to the left because it's negative 4 times. So 1, 2, 3, and 4. Do that over here. 1, 2, 3, 4. Our decimal there. Let's fill in those zeros so we see what this number actually is. And get rid of that first decimal because we've converted it now. Okay, so here we have 0.000575 on the left and 0.000683 on the right. So to compare numbers, even in decimal place, large or small, we are going to start at the leftmost or the largest digit in our number. So maybe in blue, we'll first look at the 10th place. Okay, it's both 0. So we have to look further. And let's look at the 100th place under the green arrow. Okay, well, they're both 0 again. Go orange. The 1000th place, both 0. And let's go to the next value. The 10,000th place, 1 is 5. And then over here we have 6 thousandths. So we know that 6 10,000ths is greater than 5/10,000ths. So this will be our larger number.